Hello everybody and welcome to our webinar about BIM in practice. This webinar will be about the collaboration between the engineer and the architect or the modeler of the software. So this webinar will provide an overview of the possibilities of exchange of information between the calculation software for the engineer, in this case Scia Engineer, and the BIM drawing or modeling package from the architect or the modeler. The term modeler is increasingly used to indicate that we're working with an intelligent BIM model. Today we focus on BIM tools used in engineering companies by contractors and by steel fabricators. In particular, these will be Allplan, Revit and Tekla. After a general explanation of the principles, we will illustrate this on the basis of some practical BIM examples. It is important to know that this webinar is about the exchange on BIM level. These are smart objects with smart features and design attributes. So we are not talking about the exchange with DXF or DWG files. These are, after all, simple lines without any intelligence. We're also not talking about 3D WG because here the exchange is based on general 3D volumes without attributes. And in these different softwares that we will treat, two of these software tools are part of the Scia company. Those are Allplan and Scia Engineer. So first we will start with a short representation of these two. Scia Engineer is software for the civil engineer. So you can use this to calculate all types of structures, to do calculations, but also code checks and detailed designs. So Scia Engineer allows you to use multi-materials, different materials, wood, concrete, steel, all together, aluminium, and for all types of structures. Those can be made of beams, shells, plates with ribs, all elements together. You can use them for building, bridges, all kinds of civil engineering structures. The types of calculations are not only first and second order analysis, but also dynamic, nonlinear construction stages. You can use this in multiple codes, and it's actually one of the most complete solutions for Eurocodes, but also for IBC and also different codes. If you have made some different calculations, then you can create an engineering report that you can fully customize and that can automatically be updated once you change the model. And lastly, it has strong modeling functions and is easily adjustable. On the other hand, we have Allplan. So we're going to give a brief overview of the functionalities of Allplan. Allplan is a hybrid CAD software for 2D and 3D BIM modeling of architectural structures. Allplan engineering focuses on formwork and reinforcement models and the associated lists and plans. Allplan is suitable for any type of project, simple, complex structures, infrastructures, and can be used at any stage of the project, from preliminary design to implementation. In addition to the complete 2D drafting capabilities, equivalent to that of for example AutoCAD, that are in our schedule, we mark them as basic CAD. So these are basic possibilities that other programs also have. Allplan also has BIM objects and functions for the specific modeling of buildings and structures. So views and sections to draw different schedules and plans are derived directly from the model, as well as lists and quantities. All these elements are updated on the spot when you change the model, and this guarantees a perfect coherence. Next, there is also simple and practical functionality for adding reinforcement to the model and for creating reinforcement schedules automatically from the model and to update them continuously if you make changes to the model. There are also professional tools for the visualization, a schematic or sketchy performance to render high quality images, and the rendering image of Cinema 4D, that's actually also a partner of the Nemcheck group, has been implemented in Allplan for this purpose. And also optional, you have other parts of other modules like digital terrain models, so for excavation or embankments, and city and road constructions, and etc. We now return to the collaboration between the calculation engineer and the project designer or modeler. Undoubtedly, the main challenge is the communication between these two parties and fundamental differences between the model which both parties work with. Within the BIM approach, the modeler works with a realistic 3D model of the structure as it will be built. This means that it has a high level of detail, each element is modeled as it will be placed on the building site, and this model is called the structural model. The engineer, on the other hand, needs an analytical model or calculation model. This is a simplified skeleton of the structure. Beams and columns are represented by their axes, walls and plates by their center line, and this calculation is often much simpler than the structural model. So these two models are fundamentally different, although they relate to the same structure. So you can see here for a different model, if you look at the structural model you can see all the volumes, but if you look at the analytical model, calculation model, you can see only the center lines. Now to link these two models to our different programs, First of all, you have Scia Engineer, which works with as calculation software with the analytical model, the calculation model. But in addition, Scia Engineer also includes a special new opportunity to represent the structural model. This structural model can be imported directly from another software or can be created based on priorities or the user assigns to the elements, etc. So that, for example, continuous elements are automatically recorded. The other programs are indicated CAD application and thus operate on the basis of the structural model. Within Revit and Tekla, the user also has the ability, however, to create an analytical model starting from the structural model. Allplan deliberately does not provide the last option. So Allplan works with the structural model, and the reason is that we, within the Nemetschek group, are convinced that the analytical model is the responsibility of the engineer. It is after all he or she that has to make decisions about how the structure carries different loads and how the analytical model will be composed. This analytical model is therefore the task of the engineer and his calculation software. So in our case, Scia Engineer. Now to exchange these models, we will start with the fact that Scia Engineer supports both the structural and analytical model. This means that there are two types of exchanges possible between the calculation software, Scia Engineer, and BIM CAD packages. The exchange between Scia Engineer and Allplan is based on the structural model, so path 2. The exchange between Scia Engineer and Revit or Tekla is technically possible based on the structural model, but also based on the analytical model. So this means that there are actually two types of exchange possible. The exchange with respect to the analytical model is possible via API or Application Programming Interface. The programming interface is based on technical documentation provided by the developer of the software in question. We call this product a proprietary analytical link. Scia Engineer has an analytical link with Tekla and Revit via two separate modules. The structural model, by contrast, is described in a uniform and standardized way through the EFC format. This means that the exchange in the EFC is not something between just two individual programs, but this is a general exchange. And this is also why we talk of an open platform. This is why we talk of Open BIM. Let's take a closer look to the concept of Open BIM. As already indicated, the exchange involves sharing information between two programs on the basis of a standardized EFC format. This format describes in an unambiguous way the structural model on the basis of architectural objects, even up to and including concrete and steel reinforcement and even the grids of the structure. EFC is prepared by the independent company BuildingSmart. Big software companies are part of this independent company. So for example, Nemetschek is part of it, Autodesk is part of it, Trimble is part of it, but also professional organizations, government agencies and construction professionals. This important organization monitors and certifies various software applications. You can view the list of all certified applications on their website. It is important maybe to note that Scia Engineer is since 2013 and still is the only calculation software which is certified for EFC import and export. For the BIM CAD programs, it is Allplan and Tekla that are also certified for both import and export. Revit Structure is certified for the export, but of course also intends to seek certification for the import. Now in the next step we will show you different demos about these exchanged. The first exchange will be about Revit and Scia Engineer through the analytical link, so the advanced programming interface. So we will have a model in Revit. It will include the analytical model, and this analytical model will be imported into Scia Engineer through the analytical link, in which we will calculate and modify the model in Scia Engineer, and we will send it back. It's possible to send it even back with results to Revit. For the next demo, we will show you the exchange between Scia Engineer and Tekla, but this time through the EFC exchange. So this is the EFC Open BIM link. So we will make an analytical model within Scia Engineer, and this analytical model in Scia Engineer will also contain a structural model. This is always like that in Scia Engineer. And you can create an EFC file from the structural model which can be imported in Tekla, but actually it can be imported in all kinds of different programs. And we will transfer the structural model in Tekla for further detailing and, for example, to generate blueprints. And lastly, we will also show a third model which explains the exchange between Allplan, Scia Engineer, and again to Allplan. So we'll start with a model in Allplan, send it to Scia Engineer through the EFC link. We will convert the model in Scia Engineer to an analytical model, to something we can calculate. We will use the BIM toolbox for this. And after this has been calculated and we will calculate some reinforcement, we are going to send it back to Allplan to use this reinforcement that Scia Engineer made to do some final operations. In this part, I want to explain to you a little bit about the Advanced Programming Interface, or API, a direct plugin to exchange models between Scia Engineer and Revit Structure. We have a direct link between Scia Engineer and Revit Structure because Revit Structure is an ideal program for a direct link. This is because Revit Structure contains an analytical model, calculation model, besides its volumetric model, its constructional model. For the link, you can find the plugin, and the plugin is called CADS. Now, to obtain this plugin, you must install Scia Engineer and the plugin on the same PC, on the same computer where you're using Revit Structure. The reason that you have to install Scia Engineer and the plugin, that is because the plugin will use the installed folders of Scia to look at how the program, how the project must be converted into a Scia Engineer project. So here under the name CADS, there you find the plugin or the options from the plugin. First of all, you have options. Here you can see what the general options are, or you can also configure the nodes. So these nodes that arrive in Scia Engineer, they will get a new name, for example N, then a stripe, and then 001. And there are also the general options. Like for example, the project will arrive in Eurocode. I want to exchange immediately. If you would choose the no option, then that means that an intermediary then that would mean that an exchange file, an intermediary file, is made, and the version which is installed and to which the plugin is linked is the version Scia Engineer 15. Now there are also some other additional options that can be taken into account, like for example, I don't want to exchange loads or load combinations, etc. And finally, there is also some data which you can address. For example, here you can see the user table. And in the user table, there the configurations are held. So for example, the section name for Tron, and the family name is Circle Hollow Section. In Scia Engineer, it's an RO 21.3 times 2.3. But this links the Revit section or the Revit family with the Scia Engineer section or Scia Engineer family. The same thing applies for example, materials. In Revit you have concrete cast in place. Okay, in Scia Engineer it's just C1215. You also have the user table. The user table keeps record of links that you make as a user. You have links for both cross-section as for materials. As you can see, for materials I have once already used a link for metal and concrete, and I've told them that metal was C235 and concrete was this quality of concrete. I will now delete those two. Let's save this. And in this way, now that link has been removed. So for that material, the database no longer knows that metal is linked to S235. Now we'll continue here using these options. So I'll shortly run through them in the logic workflow. First of all, you have the consistency check. The consistency check will check the analytical model in Revit Structure. This ensures you that the analytical model is correct. The reason that you have to check this is because in Revit Structure you can create volumes along with analytical lines, but that does not mean that the analytical lines are correctly connected. For this, it might be possible that the user who uses Revit Structure might have to make some decisions in order to create a correct analytical model. The consistency check will only check if the model is correct. Next you have review and export. So review and export, the review option will compare the model both in Revit Structure and in Scia Engineer to detect differences between those two. And then the differences will be exported or imported. You can see that the same thing is possible for an import. If you just roughly want to export the model without comparing, you can choose for export. Now here I will choose the export option. You can see that a new project has been made in Scia Engineer, while in Revit he is still busy running through the export window. As you can see, he has started with the export window, he is asking for a mapping. So this mapping, that is actually the data that I have removed from the user table. So the metal must be linked to something, a material in Scia Engineer. So I'm going to choose yes, I want to link this. And the material which I'm going to link to is S235. Choose OK. Now he will continue the export, but the next problem has been found for concrete. I want to add this yes for, let's say, C3545, for example. I'm going to go back again to Revit so I can keep track of what he is doing. Now in the end you will see which elements have been exported and which have not been exported. You can see, for example, that 40 foundations have not been exported because this type of element, this foundation, is not recognized in Scia Engineer. The other elements have almost all been exported, and if there would be some problem, then you can go into detail and check what the problem is. As a final step of the export option, you can also ask the program which elements have not been exported. For example, these structural foundations, I can ask him to show me these foundations, and then he will highlight them and show me what the non-exported elements are. Now we'll go to Scia Engineer, and here the model has arrived. So you can see that in fact the analytical model, the calculation model, has arrived. Now this model, if created correctly in Revit Structure, this model is directly usable in Scia Engineer. So to use this, I must add supports, because the foundations, as you can recall them, they were not exported. I have to add supports in Node. Let's say I'm going to add some supports in here, here, and in these two parts. And I'm also going to add some line supports at the base of my elevator shaft. Once this project has some supports, I just have to connect the members and nodes. I'm going to do a check, and finally the project is ready. So this is the connection, this is the check. So he has found some duplicate elements, so you might want to look into detail into the Revit model if this is something that might cause a problem or not. Scia Engineer has detected this as a problem, in fact. I will continue this model, and I will go to my loads. So normally I would have to create a load case, but as you can see, there are already different load cases here. These different load cases, they come from Revit Structure, of course. You can see under the option Analyze that Revit Structure recognizes load cases, DL, LL, wind, snow, and these load cases have been perfectly imported into Scia Engineer. I think self-weight has been added by Scia Engineer. That's the only one. And I will add some loads into, for example, LL1, live load 1. Surface loads onto the member, choose OK. I'm going to add them here on these plates. I'm not gonna use a lot of detail for this model. I've just applied some load to show you that I can now use this model to calculate it, to look at the results, and to continue further on. Once the calculation has been done, I'm going to go to my results menu. So you can see here no unusual translations. It's all acceptable, in fact. It's not like it's 1 meter. Here in the results menu, I can show you, for example, the deformations, displacements of nodes. I'm going to choose for LL1, let's say for all elements. And now you can see the displacements. Let's again refresh it. So as you can see, all elements, they have in fact a gradually changing displacement, so all elements have been connected. There are no jumps, strange jumps. Now I'm going to continue with my round trip, and I'm going to change some elements. For example, I'm going to pick a column, and this column is going to be changed. Say here, I'm going to pick all elements which I have the type column, and I'm going to change the cross section. This cross section is going to be changed. Let's pick a new one. Let's say an Scia 5, 6, I don't know, something. That will suffice, I guess. And in the next step, oh, the name, that's not logical. Change to this name. Okay, results will be deleted. No problem. I've just changed the columns. Maybe something additional. I might want to change, for example, some of the plates. Let's say these two plates. I'm gonna pick these two plates and change their thickness to 500, for example, just to show you what happens if you change elements, if you change the model. And finally, I'm gonna send this model back to Revit. Now in Revit, you still have the model, the old model in fact. I'm gonna use the CADS option, review and import. So the review option is gonna compare the two models, and it's gonna indicate what elements have changed. So first of all, Scia Engineer must prepare the model for exchange. So Scia Engineer must export it, in fact. Once Scia Engineer has exported the model, then of course Revit has got to look at its own model and the exported one. So let's go to Revit. Here is he doing something? Okay, here's the window. He indicates that different elements have been changed. For the columns, the cross sections have changed. And for the plates, two plates have changed their dimensions. These plates. And also one element has been deleted. I think this might have been a double wall. Might want to check this. Now, if I choose import, then the selected options are gonna be imported. They're gonna be changed. Well, actually, the entire model is gonna be imported, but the elements that are not different, they will not be imported. So, Scia Engineer is generating the model. This means that Scia Engineer is again preparing the model. And on the other hand, Revit is gonna import it. So let's go back to Revit. And let's see how it is importing here. That's the link. How it is importing the different new elements. So as you can see from these load cases, one has been imported. That's the new self weights. For the columns, all those new columns must be imported. So I think there are 286 columns in this model. So it's not just one or two, that's more. So we'll have to wait until those finish. And once the columns have been finished, it will probably also import the supports, because I did not explicitly configure the option to not import new supports. So plates, two plates to changement, 9 area loads, so the different surface loads which I have added into LL1. The nodal supports and line support. Okay, these have been imported. Now I can check the different parts which have been imported, or I can check the entire model. It's actually the same. He will give a warning, something with the group has changed, but this warning can be ignored. So pick OK. Now in this model, you can see that, for example, the columns, they have changed. They're now Scia 600. If I would pick the plate, is this possible? Can I pick the plate? Yes, this plate, for example. Then it should also have changed. Now I changed the thickness. So this option, this thickness here, it has changed. So it has also updated those properties. So in this way you can see that the properties are imported, that the elements which have been changed in Scia Engineer have also been changed in Revit. These changes, they happen semi-automatically, which means with the review you can check the different ones. You can accept them or not accept them. You can see what are the differences. But once you choose for import, then it will just change the Revit model. Also, with select imported, you can ask the model what has changed, show me all the parts that have changed, or show me all the new elements. There are no new elements. Or show me the geometry. Yes, the geometry changes. Those are the plates and the columns. Show me the section size changes. So those are only the columns. So you can see what has been changed. Also, here you see some buttons for getting started, best practices, help, checklist. That's in fact all documentation. So those are documents, that's information to help you use the link. Now you can also go a step further, because in the options I have shown you, or maybe not shown you explicitly, that it's also possible to import results. Now, as you saw, this import option, it took, well, several seconds, half a minute, I don't know, maybe a minute. But of course, if you're going to import results, then each element is not going to just have a different cross-section maybe, or some other different property, but it's going to have a lot of results. So if I were to import the project with results, then the import option would be a lot more heavy, would take a little bit longer. So for this reason, I've already imported a project from Scia with results. Here I saved it, a Revit file with these results. And now I can check these results. So in this model also an opening has been made here. So some different changes. I can check these results through Analyze. And here you have Structural Analysis. So this actually comes from the application Structural Analysis for Revit. So for example, I can look at the results. I have the results explorer, and I can check results from load case LL1, the other is empty. And for example, I can check the deformation. Now if I choose apply, then it will show me that you have to use the analytical model. So I'm going to go back to analytical model, and now I'm going to ask for deformation, live load 1, apply. So he's creating the visualization, and you can see the deformed structure. Oh, I'm not doing this correctly. You have to rotate it like this. Yes, you can see the deformed structure. Or you can ask for some other results, like for example, results on member forces, let's say the Fy force, and I can apply it, and he's going to show me those results. Now what you do have to take into account that Revit Structure is a program for modeling. Scia Engineer is a program for calculating and looking at results. So it is also quite logical that Scia Engineer is more fitted to work with results. But it is also possible to send your results from Scia Engineer to Revit Structure in case that the user of Revit Structure can use those results if it's useful or if he wants it. So with this, I hope I've shown you a bit of explanation about the possibilities between the exchange of Revit Structure and Scia Engineer. Of course, there are still a lot more possibilities, but I just want to highlight the most important ones. Now I'm going to show you the exchange between Scia Engineer and Tekla Structures. For this, I've prepared a project. This project is from one of our customers who is participating in our user contest, and this user has also created this module in Scia Engineer and then converted it to Tekla Structures. Now this project is completely made of steel. If I would go to the project data, you would see that the only used material is steel. Now in the next step, I'm going to export this project to an EFC file. To do this, I'm going to use File, Export, EFC. Now by means of exporting to an EFC file, I can indicate which elements I want to export. You can see 1D members, 2D members. also steel connection stiffeners. Now the reinforcement will not be important in this case, or tendons. I will export it as swept solids. Swept solids are elements which contain more intelligence than regular volumetrical elements. The regular volumetrical elements, so just volumes, are in fact the B-reps or the body representation elements. The same thing for other elements which I'm going to export. I'm going to try to maintain as much of the intelligence as possible. Next step, I choose OK. And it will generate the structural model and it will export the EFC elements. Now in Tekla Structures, you cannot just import and choose EFC file. No, you have to work with a reference model. The EFC will be a reference model. So first I will try to take a new project. And in this new project I'm going to place my EFC file. And later on I'm going to convert this EFC file to native Tekla objects. First of all, I need the project. So this is what I'm creating now, a new empty project. And in this project I'm going to place my reference model. The reference model, that's the EFC file. So I'm going to do this by using File, Insert Reference Model. I'm going to pick my EFC file. So it's here Tekla, and this is the one I just exported. So I'm going to modify these changes. Then I'm going to get the file and I'm going to place it over here. Now Tekla will import the EFC model and you have it here. Of course, this is not sufficient. This is still an EFC file. These are EFC objects. If you want to go to real Tekla objects, you will have to use Tools and then you have Convert EFC Objects. Now this Convert option will check what the elements are and will convert them into native EFC objects. First you must select all elements which you want to modify. So you can see here at the right bottom the amount of elements. Then I'm going to go to Settings. And in my settings I'm going to check whether all sections and elements are recognized. Then I can see here profiles which you cannot map. So for these elements you're going to choose a certain profile to map it with. And for the materials the same thing. Now these materials, by default all materials are recognized. So normally they are easily converted. But in this case it does not work. Why? Because these materials, they are different from the defaults. So if I would go back to Scia Engineer, then you would see here that in my materials I'm using non-default materials. So he created new materials which are not immediately recognized by Tekla. Once you mapped these materials and profiles, then it can import all these elements. In the next step, I choose Apply, OK. I can choose for Convert, and it will convert all elements into native EFC objects, all elements which it recognizes. It will give you here the report of which elements have been converted. And these elements are now genuine native Tekla objects. And this is how you can exchange a model from Scia Engineer to Tekla Structures. In our final example, we want to show you a little bit about the exchange between Scia Engineer and Allplan. We have a model here in Allplan, which we want to exchange to Scia. We're going to modify it in Scia, calculate it, and then we're going to import it back into Allplan. So in Allplan, we can look a bit at the model. We can rotate it a bit so you can see what we have in here. We can create different perspectives, so you can have an upper view, and these are different materials, the plates. And the next step, we're going to export the model to EFC. So we're going to run through File, Export, and then you can choose Export EFC Data. We can select the different structures which we want to take into account, but we just take everything and we choose OK. So we're going to save the file. So through Browse I can indicate where I want to save it, change the name. And I'm also going to run through the options just to show you that in an export of an EFC file you can also choose which elements you want to export. So in this way you can make a quick selection just on different types of elements. Let's just choose OK. Then I choose OK again. And now it will export the project to an EFC file. When the export is finished, you can see the result with the different Allplan elements and also the different EFC elements. So the EFC elements, they are here at the bottom. Next I choose OK, and this was the export in Allplan to an EFC file. Now we're going to import the EFC file that we just got from Allplan. This EFC file can also be from any other project and any other model or program, and it can be imported and exported from all software, or at least the different programs that are certified by Building Smart. So to import the EFC file, I'm going to go to File, Import EFC. Next I'm going to choose the EFC file which I want to import. It was this one. I can indicate which elements I want to import and which element not. And I can also choose, for example, if they are imported as members or as reference model. If you choose as members, then it will try to recognize the elements in it. I'm going to activate Run Member Recognizer, so the software will also try to recognize elements in the solid. So if possible, the solids will be converted into genuine Scia Engineer elements. So you see here the progress. We just have to wait until all elements are scanned, and the elements are either going to be imported as solids or they will be directly converted into real elements. As you can see, now he's running the recognizer, and in the recognizer he will transfer those solids to real Scia Engineer elements, real Scia Engineer members. You just have to wait until he finishes for all those elements. So we can see here at the bottom that it's recognizing quite a lot of elements. And if all elements are imported, then we can see the model. Elements that are not transferred, they will be solids. You can see the overview in the right once he has finished. So in the project data, I can see that there are 500 small 600 nodes, 316 beams, and 137 slabs. He used 2 profiles, 2 materials. Now of course, if there are elements which you did not want to change, which should not be changed to different elements, then of course you should have deactivated them. Now of course I can also close this model. I'm going to choose no, and I can run the recognizer myself. So if I do this manually, I can show you how it goes step by step. So I'm going to do the same thing again, but now I'm going to show you how you can do it manually. So I'm going to import an EFC file. So it was again File, Import, EFC. It was under Desktop, the EFC file. So now I'm not going to run the member recognizer, but I'm going to show you how you can indicate which element should be converted into what other element. The reason that you might want to indicate this conversion yourself is, for example, when the program is going to convert, let's say, a very short wall into a beam, or a beam that should be a wall. So if this is the case, then you will have only solids. So this is also the step that we skipped in the previous process. In the previous process, the recognizer immediately changed the solids into real elements. So here the EFC model will appear. It's just generating the model. And as you can see on the right, there are no nodes, no beams, no slabs, only solids. With the BIM toolbox, I can convert these elements into real Scia Engineer elements. So I'm going to pick, for example, this slab. I'm going to choose all elements which have a role slab. And then with the convert, I'm going to say convert these general solids into plate or walls. You can see that 11 slabs were recognized. Also, due to the intelligence in the EFC, so due to the intelligence that is given by Allplan, Scia Engineer can also recognize immediately the correct material, the correct layers, and correct information. There is also some additional BIM information or special information that is transferred through EFC. Like, for example, you can see this element has certain representation, EFC identity. Those elements were also transferred. I can do the same thing for the columns. So for all these columns, I'm going to ask him to convert them into beam column. It will recognize automatically which cross-section that it has, and either the cross-section will be recognized as either a library cross-section or a certain general rectangular cross-section, and if it is not recognized, Scia Engineer will draw for himself the cross-section and then derive the properties from that cross-section. And once he is finished, you can see that all these elements are now columns. If I'm going to pick just one, then you can see it has received a general cross-section. This general cross-section has the shape of an Hygiea, in fact. Or here at the bottom, you can have rectangles. And as you can see, the wall, that is actually a sort of L corner, but it will also be correctly converted into correct Scia Engineer elements. So to be correct, I'm gonna pick wall, the role wall, and convert those elements. Let's see, I'm not gonna convert these elements at the bottom. Why? Because they will be just supports. This kind of foundation does not exist in Scia. I will just use supports. So general salt into the wall, and 44 slabs were recognized. Now this is the model that I will work with. The foundations will not be converted. And if you convert an EFC to Scia Engineer objects, to a calculatable model, you will have to check if the angles do connect correctly. So for example here, you can see that these do not connect correctly. How can you solve this? You have the align option. So if I'm going to pick align, the align option is going to be executed for all elements which are selected. So I'm going to select nothing. If I choose the line, he will ask me, do you want to proceed with all entities? It's fine by me. I'm going to say which elements he must use. So let's say the ground level and then the 2D planes, and he can extend them. Next, I'm going to look in the master plane window. Here you can see which planes are used. So this plane will be used for alignment, and also these planes. The vertical and horizontal planes will also be used. The vertical will be these walls. Nodes that are close to these plates will be aligned to these plates, so to these planes. Finally, I'm going to choose the Run Align option, and you will see that here an alignment will be made. So with this option you can align different elements, you can connect nodes, and you can in fact fix the model. The reason that you have to correct or fix the model a bit, that is because volumes do not connect the same way as you want with your system lines. In these connections, it is also possible that you work in small steps, because the procedure in making the connections between the different elements, they also involve some decision-making steps. Now in this project these decision-making steps were minimized, but of course in other projects they can be more important. Next step, I'm going to add some supports. So in structure I'm going to go to model data supports in nodes. I'm going to add hinged nodes at the bottom. And finally lines on 2D member edges at the bottom of the rigid core. If you have done this, then you have a model with which you can calculate. So I'm going to do the final checks, the connect members and nodes, and the check of the structure. And lastly, I'm going to apply some loads and calculate the structure. So for the different load cases, you will see that no load cases exist. So for example, a load case self-weight, it will be sufficient, and you can calculate the project and can see whether or not the deformations are realistic or not. So here you can see that is a total deformation. I can go to my results menu, show you deformation. It's a bit the same thing as earlier. For self-weight, let's say for all elements, this will be the deformation. Now in a final step, I'm gonna go to the concrete menu. And let's say for the lower columns, for these, I'm gonna ask member reinforcement. So I'm gonna do an automatic reinforcement design for current elements, load case 1, and I will calculate the reinforcement. So now we have added reinforcement for the lower columns, as you can see here. And next step, we will export this project once again to an EFC file. So this can be done through File, Export, EFC. So let's call this Scia Engineer 2. And you can save the different parts which you want to save. You can indicate which parts. I'm just going to export all of them. As you can see, not only the elements, columns, slabs and solids are exported, but also the reinforcement bars. In the next step, we will go to Allplan and we will continue with this reinforcement. So in our final step, we're going to import the FC file again in Allplan. So first of all, we're going to create a layer, a separate layer for the reinforcement. So we're just going to import the reinforcement into the existing model in Allplan. So I'm going to create a new structure. This new structure will have the number 40 and I will call it rebar. It's something specially foreseen to store reinforcement. Okay, so now through File, Import and EFC, I'm going to import the EFC file. So then I'm going to go to the settings. In the settings you can see that it's possible to import all elements, but I'm going to pick my favorite, and my favorite is rebar, and in rebar only reinforcement is ticked on. Next step, we're going to choose OK, and we're going to continue with the import. Now when the import is done, I'm going to indicate that the file must be stored in number 40, rebar. Then you will see a report indicating which elements were in the EFC file. So you can see the walls, the columns, the lower and upper slab, and you can see also the reinforcement which is in the EFC file. After which, you can also see which elements were created in Allplan, and the elements which are created in Allplan, that's the reinforcement. Okay, now we will see the reinforcement. So this is actually all that we have imported, and you can see it in 3 views. Okay, we're going to activate the layer 30 and 40 again. So we're going to see those two. You can see the entire structure. Now in these columns you have reinforcement. So we're going to add a transparent surface. And this surface will be applied onto the columns. So for the component column, I'm going to pick these columns. And they will now become transparent so you can see the reinforcement. Now for the reinforcement, I'm going to deactivate the perspective, and you can see the reinforcement here for the entire structure. I'm going to activate the perspective again, and we're going to create some planes, some views. So first of all, let's pick an isometry, and we pick this column. Here for this column, we're going to look at reinforcement. So we're going to make a reinforcement schedule. First of all, I'm going to create a view, a free view for this element. I'm going to place it here. Then let's add a normal view for the same element. Let's place it here. And a linked view, so an associate view for the other direction in the same height. You can place it here. Okay, finally, I'm going to indicate that the reinforcement should also be in the different elements. Okay, so here you can see the reinforcements, and for this reinforcement I can add, for example, under engineering, dimension lines. So I'm gonna add them for the stirrups here, and I can place the texts. Okay, so here you can see a picture of the reinforcement in two views. Let's add another part for the top view, and for the top view you can also see the reinforcement in the element. Now here I'm also going to add some dimension lines, so under engineering I'm going to add a label, and here you can see label for the reinforcement. Okay, finally I also want to add a reinforcement bar legend. So this legend, you see that it's quite long because the elements in Scia Engineer have been indicated, have been found separately. So the different stirrups are found separately, but that's no problem because we can reorganize it. So by using arrangement, I can rearrange all these elements, and it will detect that the stirrups have the same shape, and it will combine them. Okay, so here this bar schedule is more compact. Now finally you also see that here the labels have changed, so this number 29 has become 1. And let's see, what else can we display? So we can also change the bar distance. For example, instead of 276 I can pick 200 or 75, and you can immediately see it changing in the model. Also on the left you can also see it. Also in the legend you can see it changing everywhere. Now in my views I can also go to this view and add some more information. Now if I undo or redo, you can see these changes immediately. So it's linked, the views are linked, and if you change something at one edge, then it will change in the entire model. Okay, for example, if you want to add some cover at the bottom parts, you can just simply move it a little bit, and it's also changed in the big view, in the big picture. The same thing can be done for the top side. So just move the top reinforcement a bit, and then it's changed. Then you have some cover. It's also immediately changed in the big picture, the 3D picture. So undo, redo, and then you can see again clearly what has been changed. Okay. Now finally, maybe I want to add some dimension lines for the longitudinal reinforcements. So just pick these bars and can choose where I'm gonna place this. Let's say for example at the left side, and I can place my legend. Okay, so now maybe rearrange this a little bit. Let's see. Okay, so we can move these windows a little bit together, make it more compact. Okay, now this is the reinforcement schedule which has been created for the elements. Now you can do the same thing for other elements. You can also modify it here, and you can do a lot more operations. So this is what I want to show you about the exchange between Scia Engineer and Allplan. And as you can see, it is very easy to exchange different models, to import and export, and to import EFC files in Allplan. Now as I've shown you, you have seen the direct link between Revit and Scia Engineer. You've also seen the exchange by EFC. This exchange has been used between SCIA, Tekla and Allplan. And of course, you can also use it between other programs. Now to conclude, as you can see, the exchange, so the exchange BIM is all about exchanging information. It's building information modeling, BIM, has been done with Revit, Allplan and Tekla. And here we show you a summary about which different links are possible between the different programs. So you can see that analytical link is possible between programs that support an analytical model. And the EFC, structural model link, is possible between Scia Engineer and all CAD programs. Of course, between Allplan and Revit you can also exchange through EFC files. Now since we have shown you both the analytical link and the structural link, so the analytical API and the EFC format, we want to give you our opinion about the advantages and the disadvantages of both. So first we will start with the analytical link. So with this exchange, it's very easy to exchange back and forth. You can send a model from program 1 to program 2, and then again from program 2 to program 1, and you can keep building on the model in the other program. In an analytical link, you have to make the calculation model within the drawing software. So this can be an advantage or a disadvantage. But in any way, you need a good interaction between the modeler and the engineer, the one who draws and the one who calculates. So this makes actually the analytical link good for small teams, or maybe even better if the modeler and the engineer are the same person, because it's difficult to control the workflow. Why? Because you change something in program 1, you send the model to program 2, the person in program 2 modifies the model and sends it back to the person in program 1, but then in program 1 the model is changed, but that person does not know what has been changed, or not exactly. You have to communicate what you have changed, because the model itself is already updated, but you're not sure what. On the other hand, there are also some limitations due to this link, because it's an advanced programming interface. This interface needs to be updated when the individual programs are also updated. So the link depends on the versions of the used software. Therefore, we can ask us some questions about whether this will be able to maintain forever, because the software keeps evolving and the link must also be maintained. Now, on the other hand, we're going to talk a bit about the EFC. In EFC, you're not going to update each time from the last program where you sent the model from, but actually you're going to use a reference model, which means that if person A, B, and C are going to update their model, they're going to report it, because there also has to be some communication, but they're just going to report it. Well, comparing to the reference model, I've changed this and this and this. And then the calculation model is made in the specific calculation software. So you're going to exchange the volumes, the structural model. The calculation model is made in specific calculation software, which has the advantage that the calculation engineer, or the calculation person, is going to make the decisions about how to create this analytical model. The modeler is only going to draw the model. It's only going to draw it. So this makes it very good for multidisciplinary teams. And it can be said that this is actually a sort of global solution. And since EFC is certified by Building Smart, by an independent company, this means that the exchange is independent from your software version, even independent from the software program. And the existence of this exchange will be guaranteed, because there are different codes to indicate you need these and these and these specifications to be certified for EFC. And also you cannot just send a beam and a plate, but also different data, other properties, reinforcement, connections, grids, etc. So you have the analytical link, you have the EFC link. Both have their advantages and their disadvantages. We just want to show you the different possibilities. Now, if you would have any further questions, you can always consult this webinar and other webinars that already have been recorded. You can find it here on our website, but you can also find it on the YouTube channel. For our channel, it's Scia Officials. And if you would have any other questions, you can contact your account manager, or you can contact us on sales@sciaonline.com. And if you would have any practical user questions, you can contact us at support@sciaonline.com. Thank you for your attention, and if you have any questions, please feel free to contact us.